Hello and welcome to this week's edition of Underserved, the podcast for the rest of the tech industry. I'm your host, Andrew Gelina. I am lucky to be joined today by Tim Callaghan, VP of Technology at Crunchtime.
Good morning. Good to be here.
Thank you very much for coming out on this snowy Wednesday. So, Tim, a question I often open with folks is, how did you kind of get started, get excited about programming and technology way back in the day?
It was the mid-1970s, and my father was an officer at a small savings and loan in New Jersey. And I clearly remember one Saturday morning him dragging my brother and I into the office. And he had a dumb terminal on his desk hooked up to, I'm assuming, some kind of mini computer or maybe a mainframe in the back end. And he told us about these games that he could play at work on lunch. And the game he brought up was football. And I remember my brother and I entering our names, and it was myself against my brother Mark. And the game was super simple, obviously written in BASIC. Offense, you would pick pass or run or special teams. You could throw a long pass or a short pass. And on defense, you had to look away when one person would enter what they were doing so that you couldn't cheat. And to this day, I remember my brother threw a long pass, and I was defending against a run. It must have been a third down and short. And he threw a 76-yard pass, and it was nothing more than the computer saying he threw a 76-yard pass, which went for a touchdown. And I was hooked at that point. I just could not believe. We would play Stratomatic football at the time, which seemed exactly the same thing with dice. But the fact that the dice were gone and the board was gone and it was all words and imagination, it was something new to me that I'd never seen before and couldn't imagine what was going to be possible.
That's cool. A lot of folks we've talked to, like a game got them hooked, way back in the day, like playing Adventure or some text-based thing, or just the fact that there was this relatively simple algorithm, but, intermediating or making a Dungeons and Dragons or a football experience just a little bit better with a computer.
Mm-hmm.
I wanted to program games on the VIC-20. That's what got me going.
Yeah. And at that point, I knew, I had to know how it worked. So I saved my dollars. And a few years later, Timex Sinclair, there was a TS-1000, it was called. And it was $150 built. Or if you wanted to screw it together yourself, it was $110. And I've always been frugal, even as a child. And I assumed, why would I I could save $40 by building it myself. Of course, I'm going to build it myself. So the TS-1000 showed up, hooked it up to my television. And back in those days, there was no software to purchase. It came in a magazine and you typed in a basic program. And then I would tear it apart and figure out, I taught myself programming by looking at other people's code and changing it for my own purposes. And then over time, it became the next system. So the next system you mentioned, a VIC-20, my next real system was a Commodore 64. And programming on that, same thing. It had BASIC. I would do the same thing, BASIC out of books. But I realized in a hurry with a Commodore 64, the real games were built without BASIC. People were doing assembly or machine language. I didn't even know how that an assembler could exist, but the Commodore 64 was great. It was back in a day when the computer came with a manual, and the manual had basic instructions and how they worked. And it also, the Commodore 64 had the opcodes. So I would write machine language. And that's how I taught myself how to program things that were fast and graphically interesting. On a Commodore 64, I would download software off bulletin boards and pull it apart and look at the machine language and change the machine language for my own purposes to do fancy graphics with sprites, find out how to do music in the background with multitasking and have the computer doing two things at once. I would put smooth scrolls at the bottom, and I started developing intro screens for cracking groups back in the early 80s to mid-80s. And that was my next leveling up of my programming abilities. And then fast forwarding to further in high school, my family got a TRS-80 Model 3. We had Model 3s at school. I took a BASIC class. It was super simple since I had already learned BASIC on my own. And I had a teacher, my math teacher, willing to teach me Pascal in high school. And that was interesting as well, which was I was a hacker learning to code on my own with machine language. My documentation was a piece of paper because if I ever forgot where my addresses were in memory, my program just stopped working. Learning BASIC was really good for me to help understand structure and the proper way to write code. And then that took me to college. I ended up applying to one school and one school only. I grew up in New Jersey. The school I wanted to go to was Northeastern. And the two reasons I wanted to go to Northeastern were the Red Sox in Boston. I was a Red Sox fan in New Jersey, kind of a fish out of water.
That's unpopular.
Not when it comes to baseball cards. You can make a lot of money by selling Yankees for more than they're worth and getting Red Sox for half price. Northeastern for that and for the co-op program. The co-op program ended up working out really nicely for me. I got a job at Boston City Hall in my second year at Northeastern, and I learned how to program in Clipper, which was a D-base compiler from way, way back in the day. But the best part about that job, other than learning about databases or a little bit about databases, was software development lifecycle, the SDLC. So I look back at my time at Boston City Hall and I think it was kind of crazy. They were, kids that were 19 years old were building applications for tracking trees for the city, or tracking the last, how do they maintain basketball courts, or the police department needs an application. And we would go in and do requirements. We would code, we would QA, we'd write documentation, we'd do deployment, we'd do maintenance and bug fixes. So it was a really good experience for me to see end to end what that software development was more than just sitting down and writing lines of code.
That's cool. Did they use version control way back then? I know I didn't. Until I hit the professional world, I had never seen it.
No, version control was kind of on your own. Early on in the late 80s at City Hall, we didn't even have a network. So version control was 3.5-inch floppies with labels, and you'd write, you'd hopefully take a backup every week or so of the state of the source code. And while we were there, they installed Novell networks at some point. And at that point, we could at least keep a copy of our code on the network. And hopefully there was a network administrator making backups. But there was little thought about keeping track of code over time, as opposed to the current state of code is kind of what matters to the application. Mm-hmm. Given that the applications were relatively simple, we were writing tracking systems, not the city's payroll system or the HRIS or that type of application.
Right. So fast forward through your career to today, you're VP of technology at Crunchtime. What does Crunchtime do?
Crunchtime does back of house software for hospitality, mainly for restaurants. We also have quite a few customers in the cruise industry, because a cruise ship is essentially several restaurants in one moving object. So what makes supply chain difficult for cruise is you order something when the ship is in Miami, and the delivery of that item might take place in Aruba. And if the food's not there in Aruba, there's no Costco to pick it up should it not arrive. So it's supply chain we did first for cruise, which was interesting. We solved a hard problem. When you have a restaurant that can't move, it's a little easier to make sure when you order on time, your order tends to be delivered on time, unless there's a snowstorm or hurricane or something else. So we do back office is it's all about food and beverage management and human resource management. The difference is in a restaurant, you have two pieces of software primarily: back of house Crunchtime, and then the front of house is a point of sale system. And that's where you take orders, customers pay for orders, and it's a time clock system for the restaurant. What I focus on at Crunchtime is two things. One is integration to point of sale. So it's very important that both systems be integrating in real time. So if a person gets hired, they get set up in Crunchtime, that person has to be in the point of sale before the person shows up for work, or they can't clock in and get paid. And in reverse, we want to make sure that as sales are going on in the restaurant, in the point of sale, that data goes to Crunchtime, so we know we can deplete inventory and avoid running out of items. The worst thing at a restaurant is when a menu item is 86th and not on the menu anymore because they ran out of the materials to make the item. Sometimes with a limited time offer, it would be different, but you don't ever want, say, a burger restaurant to run out of beef, or there really is nothing to sell.
Oh, interesting. Do you guys work with Royal Caribbean?
We do. Yes, they're one of our customers.
Oh, cool.
We have about 80%, 85% of the cruise industry. It started with Carnival back in 1999. Through the years, many other cruise companies have adopted Crunchtime.
Well, thanks to you guys on our last cruise, I got the same meal every night that I wanted, just the way I wanted it every darn time. Before Crunchtime, you were at Tokutech, and I think you had some interesting stories about embracing open source and competing with it and so on. Why don't you tell us a bit about that?
Yeah, I think there's really two lessons I learned at Tokutech in the open source and in a world of sharing your code. So the first one was, you mentioned source control earlier, and I've always been a fan and a user of very simple version control software like Subversion or maybe even CVS back in the day. My mind was blown when I first learned about Git and GitHub. It just distributed how it does pull requests. It was very new to me. You asked about version control software at City Hall. My early years at Crunchtime in the early 2000s, I was the only database developer, so my version control was I would create a folder for each release, and the current code for that release would go in there. And if I ever needed to see what changed between versions, I would just diff, and that was good enough for me. I didn't have comments about why things had changed, but as the only developer, and I have good memory, it never was a problem knowing why I changed a line of code. So with Tokutech, we put our software in GitHub, and I was one of my roles at Tokutech was benchmarking, comparing our software against MySQL within ODB, for example, or later in life, our version of MongoDB against MongoDB proper. So in that spirit, I would create benchmark applications, and I would put them in my repo, and I would use them in my benchmarking, which helped if a person wanted to see exactly what I was benchmarking, given that the code was available, they could always take a peek and decide whether or not this test was fair or what the test was actually doing for a performance analysis or a compression analysis. And quickly I learned it was a hard thing for me to accept was I put my benchmark applications in GitHub. After a little while, I should have been flattered. I got my first pull request. And then a few more showed up. And I realized that it's a two-edged sword putting your code on something like GitHub. In one instance, you want people to contribute and help, or minimally, you want people to care. You want people to, like your repo. But when a pull request comes along, what a person is saying to you is, hey, I have a feature for you. Or maybe it's a bug fix, which is a little easier to take in. But with a feature, it might be a feature you just don't want. And it's a little bit rude to ignore the feature, but at the same time, it might add complexity or just make your benchmark behave differently. And you end up in a world where you might get forked if you don't do something about the PR that's in front of you, and you get a person excited and multiple PRs start showing up. So it was hard for me for a while to click that first merge button on a PR and accept someone else's feature into my product. And some of the early stuff was easy. It was how I was authenticating with MongoDB, for example, could have been done better, and there was a better way that showed up. But some of it was re-implementing a similar feature I already had in a way, to me, that was more complex. And so I had to reject some PRs. It took a while for me to get used to living in a world where that's part of what you're doing is contributing, but also to put yourself in the person's shoes who owns the repo, as I'm doing PRs for someone else's product or project, and coming at it from an angle of, sometimes maybe asking the person first, hey, I've got a great idea for a feature. And before I spend a bunch of time, if I should just fork, let's just fork now. Like, let's not build a little animosity in the work that I've done.
No one wants to hear their baby called ugly.
Exactly.
On either side of that fence.
True. Yes. And my benchmark code, as the next story will show, is definitely a baby that's ugly. I can share that. I've always had a mentality with benchmarks in that I need to get a benchmark application that's going to be fair. That's going to, if I'm going to compare A to B, it should at least make sure that it's giving A and B a shot at being the best that they can do for performance, for example. Most of my benchmarking has been performance related. Some of the benchmarks that I created that I have in my GitHub repo are all about implementing something called Sysbench, which existed forever in MySQL. I created a version of Sysbench to run against MongoDB using MongoDB's wire protocol. And I also, there was a benchmark called IIBench, the indexed insertion benchmark, which was, long used for MySQL. And again, I implemented a Java version for MongoDB. In my benchmark applications in general, I try to keep them very expressive, very self-documenting. You should be able to read and tinker with the code if you want to. But the goal of a benchmark application in my mind is test the software, exercise it to be fair and to be as accurate as you need to be for the measurement that you're trying to take. The story goes, MongoDB has always had a conference once a year they call Mongo World, which is generally, and I think still, in Chicago or maybe in New York, in the US every single year. And then they would have smaller regional big conferences, like one for Europe that was held in London every year. So I was at Tokutech at the time, and we'd forked MongoDB and created our own version called TokuMX, and same wire protocol. The argument was drop-in replacement, right? That's what everyone wants to hear. The point of the drop-in replacement needs to be like, why would I drop in something else? Well, TokuMX had transactions, which were foreign to MongoDB at the time. It had amazing compression, so size on disk was tremendously smaller than pure MongoDB. And it had some really interesting high-performance ideas in it, things that would go much faster than pure MongoDB because of how Tokutech had some patented indexing technology. So I'm at Mongo London, and I'd long been benchmarking against Mongo and blogging my benchmarks to try to attract customers and get people to use the product, either the open source or the open core, the paid commercial versions. And I'm at the conference, and we had a booth. Mongo was, kind enough to allow a competitor to have a booth and sell against them. And we were kind of the only company doing that. So it's a weird position to be in. Not often in life is there a presentation going on at a conference that is basically the presentation just for you. So it could have been a presentation where if I was the only one in the audience, it would have been perfect. It's exactly what I wanted to see. And the presentation was how we benchmark MongoDB. The small letters underneath it should have been how not to benchmark MongoDB, as I learned as part of the presentation. So it was at the conference, they had a gigantic ballroom, the main presentation area where this one was taking place, and then some smaller ones around it. So it was kind of one of those headline presentations, and it was going to be presented by, I think, the main performance architect at Mongo, who was, for some reason, couldn't be there, but it was his slide deck being presented by someone else whose name I didn't recognize. And I go into the ballroom, and it's packed. There is not a seat there. There must have been 600-700 people because it was right in the meat of the day, maybe before lunch. So no one was leaving. Everyone had to go to something. So why not go to this presentation and just see what Mongo does internally to make their software more performant? And I sit down, and the presentation starts. And the first slide that comes up after the speaker introduces himself is a screenshot of about 20 lines of Java. And I'm sitting in my seat looking at this Java, and something seems vaguely familiar about what I'm looking at on the screen. And after about 60 seconds or so, the screen with my code on it, I realize it's my code. As the presenter is clicking, it's doing the classic a lasso around some text and an arrow pointing at something in the code that's just plain a bad idea. So the first thing that's pointed out in my code is just how inaccurate the timing I was doing. So in Java, you can get the number of milliseconds since the epoch, I think, is 1. But there's also a way to get microseconds. And the microseconds variant is super accurate, whereas the millisecond might have a variability of 5%. And so pretty much every single line of code I had up there, maybe other than picking on my style and indentation, was pointing out everything this benchmark did wrong about trying to measure performance. And then fast forward 2 slides later, it's my other benchmark and a similar dissection of every single thing that this could have done better in terms of being a benchmark application. So rather than the presentation speaking about how much better MongoDB is getting at performance, how much faster it is in the releases, the ideas they have coming in the future, for the first 50% of the presentation, it picked apart how not to benchmark MongoDB. And much like the pull request in GitHub, it was probably the most humbling hour of my professional career because the entire time I'm fuming. I probably have my phone out and I'm texting my coworkers, showing screenshots of what's going on, and my blood pressure's going up. It was the perfect storm of everything. And at the end of the presentation, there was time for Q&A, and I could not have raised my hand faster. As luck would have it, even with that many people in the room, the microphone came to me first. And I stood up and I said, let me start by introducing myself. Tim Callaghan from Toku Tech. That was my code you picked apart. First of all, there was a rousing laughter, and everyone thought it was just so funny, but it was completely unintentional. The speaker, first off, apologized, but let me know it wasn't his deck that he was presenting. But afterwards came up to me, and we had a really good, spirited conversation about it. But from a humbling perspective, it's putting yourself out there with open source. It's different than when you're developing at a company and it's closed and you're doing code review with your peers. It's more personal in that the world is your code review, and everyone has a right to an opinion, and you have a right to defend why you do certain things. But not knowing it was coming, it was just, I'm so happy I was at Toku Tech. I wrote what I wrote. It was on GitHub. I was at Mongo London. That presentation used my code. Like the number of things that had to happen for that moment. But without that moment in my career, I think the pull request example is just a much smaller version because it wasn't personal. I wasn't in the room with the people and seeing, while my code was being dissected, I could tell people around me were taking notes. Don't do this. Don't do this. I'm going to grab this deck because this is the worst way to capture time for benchmarking anything. It's like a webinar. You're muted. Like in the middle of a presentation, I can't stop him and defend my code, but man, did I want to.
Underserved is brought to you by Sirix, the developer-founded, developer-run software consulting company. Do your kids want to see you at more of their soccer games? Does your daughter want you to come to her dance recital? Does your son want you to help him with his homework, and then maybe watch a show together? Of course they do. But it's getting harder and harder for you to have family time because you have to put in so many hours at the office to get your mountain of software projects completed and out the door. And you can't hire people fast enough in such a tight job market to help you catch up. If this is you, then it's time to call Syrinx. We have consultants who can slot into your team immediately to make a positive impact on your schedule. We help you ship software on time and on budget. And we help you get back time to do the important things in life, like having a life. Let us get started today. You could reach us at 888-579-7469, option 1. That number again is 888-579-7469, option 1. Or you can email us at info@syrinx.com. That is info@syrinx.com. More time with your family, brought to you by Syrinx. Having your code reviewed by anyone, like coding is a very personal thing at the end of the day. You're using your brain and your knowledge and your experience to bring something to life. And that's kind of the art side of what we do. Mm-hmm. And, two people might write the same routine completely differently. And maybe one is more elegant and one is more efficient, or, maybe the guy on the right has both of those and the guy on the left doesn't. And you're kind of putting yourself out there and having other folks, even like you said, at a company doing a code review. Depending on how everyone is about it, it can be very contentious and humbling or even degrading if everyone's hammering on you. Or it can be a good experience where everyone wants the best solution, wants the best code, everyone learns from one another, and there's a quick cross-pollination of ideas. But yeah, you're right. Open source definitely takes it to the next level. And God forbid, being at a conference and having someone walk through it can definitely do that.
And I think, too, it comes from the years of service, right? I think that people who come out of school now and start coding, things like distributed revision control software like GitHub, lots of peer review, not working on things on your own, where your code is landing. I think you get trained early nowadays, where I'm 50, and even in my 30s, I was coding on my own. It wasn't a 2-person or a 5-person opportunity. So I think in some ways to retrain yourself to be comfortable with someone else questioning code that works. Could it be a little more efficient? Could you have made it a little simpler? Do you have enough comments? Is it have you built in logging and observability, right? There's lots of angles now where some people come to a code review with an agenda. This isn't observable. Like, this isn't going to log enough for us to deal with it should it crash in production. And there's that fine line between when is it done? When is it good enough?
You mentioned your brother Mark before. Is that the same brother that you were submitting some stuff to Mongo and kind of competing over?
It was. Our paths have crossed. My brother worked at Oracle for a handful of years. He went from Oracle to Google to help them improve MySQL in the early to mid 2000s. Created a bunch of patches, crash safe replication, some other things have occurred there. Then he went to Facebook and did a lot with MySQL. He's kind of the reason I got interested in working at Tokutech and working with MySQL. And MongoDB every year, they don't do this anymore, but they would come out with a new release every June. And prior to the release, when they had something beta ready, they would announce a bug hunt, which is a little common with other software products nowadays. But with Mongo, it was kind of a new idea at the time. So every time a new release would come out, they would have this bug hunt, and anyone on the planet could try to find defects, things that crash, things that incorrectness. I would primarily focus on performance. And 2 years in a row, I came in second place in the bug hunt, and my older brother, Mark, came in first. And it's interesting, kind of all these stories come back together. The very application that was used in that how not to benchmark MongoDB was the application I ran in one of the versions of Mongo that won me second place in the bug hunt. It found an extreme performance regression in MongoDB, like a factor of 100, where an insertion benchmark might have done 1,000 documents per second. It was down to like 1 document per second, running the very application that in the presentation it was pointed out that this is not how to benchmark MongoDB. So I kind of find it funny that full circle, it all came back together. But yeah, they were good times. I mean, my parents got a good laugh out of it. I got pictures with him where he would go up on stage and receive the first place award, and I would be sitting in the front row with the second place award. So I'm still looking to beat him at something professionally. And recently, he's actually just decided to join MongoDB on the performance team. So it gets even weirder, kind of folding back on his own. So maybe he'll take my benchmark apps and and use them internally and get something good from it.
Very nice. Now, in addition to benchmarking MongoDB in particular, I think you did some work with kind of pitting the cloud providers against one another and how well they perform. What did you find there?
I did. That was a small on-the-side paid engagement with VoltDB. What they wanted to do was to see, taking a standard VoltDB benchmark that I created when I was at VoltDB as a sales engineer, and run it on various cloud providers. Their goal was to see, do some cloud providers perform better, specifically using VoltDB, but as an in-memory database, it was meant to be, at a certain price, can a certain level of performance be achieved? And should price not matter, how much performance in total can you get out of the various cloud providers? What was most interesting to me was, number one, out of the box, for some reason, AWS had some config that wasn't easily seen that caused VoltDB in AWS to be the worst performance-wise. And after I blogged, AWS reached out, talked to me about this. I just never had the time to go back and re-benchmark with some of I think they wanted me to change some kernel parameters on the servers, which to me a little bit is cheating, right? Out of the box, it should just work. What the write-up really became was everyone's pretty similar. Everyone's running similar hardware, and cost-wise, everyone can be within 10 or 20%. What I found interesting to talk about and blog about was my experience with the user interface, with provisioning servers, with decommissioning servers. I found in the IBM cloud, it was fascinating to me. You could provision bare metal servers, and you felt like you were at Dell.com. Everything was tunable. How many CPUs do I want? Exactly what CPUs do I want? How much RAM do I want? And within hours, the server was available. So I don't know if it was humans or robots building out super micros, or they were doing something to get me exactly what I wanted, or maybe giving me more than I asked for and kind of hiding the extra cores or something. But it was fascinating, number one, being able to get bare metal quickly. And I think all cloud providers have now caught up in that. But really, it came down to the UI. And I found that AWS's user experience was phenomenally better than everybody else. And I would say IBM was kind of in second place. This was back in 2015. Azure had some catching up to do, and I think they've done a pretty good job at this point. I forget who the fourth cloud provider was that I put in the mix.
The Google Cloud provider?
Google Cloud. Yep. And again, Google Cloud, their UX was very, very responsive. I mean, that was the one thing that concerned me back then about Azure, was it was just extremely sluggish as you're walking through configuring a server or how to configure a batch of servers. I think I had to do them one at a time on Azure at the time, where everyone else, they just want the money. So, hey, you want 12 biggest we can build servers that are $20 an hour? Like, why not make that easy to spin that many up?
I think most of them have done a good job of making it easy to spin up new servers or auto scale or put something like that in there. The one challenge we ran into was scaling down. On Azure in particular, there was a search index that you could provision, and you would have it crawl documents and get your keywords, and then you could hit that from your code in order to provide search results. And a client had provisioned an instance that was clearly too large for what they needed, and it was costing them $400 a month or something like that. It probably should have been about 40. And so we're like, all right, we'll just scale that down. Nope. You have to stand up a smaller instance, migrate all your data, repoint the code at the smaller instance, and then you can nuke the big one. I'm not terribly surprised they haven't put a lot of work into, helping people scale down, but it can be a tough exercise. You can paint yourself into a corner. I saw the same thing with AWS. It seemed like they're with a little bit of a head start in the market, and with the UI, they seem to have done a better job of making it relatively easy to manage everything. But we're thinking of doing an episode called The Dark Side of the Cloud, where we talk about some of the runaway costs and things that can happen if you're not careful in managing it, or just in SaaS providers in general. Well, we've covered a lot of cool topics. We're going to put some items in our show notes. So if you're listening and want to learn more about some of the topics we've covered, those show notes you can get at underserved.libsyn.com. That's underserved.libsyn.com. And we also invite you to interact with us. Tell us what you think of the show, or if you're interested in being a future guest on the show. The way to get in touch with us is underserved@syrinx.com. That email again, underserved@syrinx.com. So, Tim, you mentioned that you also like working with the next generation, getting them excited about technology and programming, including working with your son. Can you tell us a bit about that?
My son, I think early on, he decided he wanted to be a programmer because he would see me coding and enjoying my job. And it's financially rewarding. So it had kind of all the properties of what might be a great career. And early on, I was nervous that he wanted to do it because I do it. And I was hopeful that he would figure out why he wanted to do it before he decided to major in computer science in college and then go on to be a software developer. So early in, his 7th and 8th grade, he went to some of the ID Tech camps and did a little bit of coding and hacking and took computer science for a few years in high school and coded on his own a little bit, mini projects here and there. And he's done some internships at my company. The most interesting project I did with him was when he was a junior in high school in Wakefield. They have a STEAM committee, which is STEM plus arts. But they would have a night at the middle school where all these vendors would come in and have booths like iRobot and AWS Robotics, and some local animal places would bring in animals for people to look at and talk about biology. And when I found out about STEAM Night in February of his junior year, without talking to him, I sent in $100 and I signed us up to have 2 tables. And the sign up said, we called ourselves Hack Wakefield, and we were going to create a game in 30 days and present it at STEAM Night. So he got home from school that day, and I said, Thomas, there's a STEAM Night coming up next month, right? And he's like, yeah. I signed us up, and we're going to make a game, and it's going to have rules. The game needs to be educational, and the game needs to be controlled by nothing more than a webcam. And I think at that moment, his head exploded. And I never thought about him at that age, right? Like it might be a little embarrassing for him to be there with his dad because we're oddballs. There is no father-son, create a game, come to STEAM Night, do this. We were kind of on our own putting this together, and we only had 30 days. Quickly, we sat down and did what you would do with any project. We came up with a design. I said, it needs to be educational, so let's do something with math. So we called the game Mathletics. And if we're going to use a webcam, almost like a Kinect for Xbox, I said, let's not do anything too crazy, but I don't want people touching the keyboard to put in answers. I've been using Python for a few years now. I'm a big fan of Python. I said, well, for starters, I'll start thinking about the foundation of the game. Like, what does the game have to be? It's going to be addition and multiplication. It needs to have easy and hard modes. I said, so I'll write a quick version of the game in Python that's just you're hitting keys on a keyboard, right and left, almost hearkening back to the days of my football game with my brother and my dad. And I said, the fun is going to be the webcam, because if the game is nothing more than people hitting keys on a keyboard, not really that interesting. So he went off and did what I did as a kid, which was he hacked. And in a world with YouTube and the internet, it's much easier to be a hacker nowadays than it was back in the day in the 80s. So he quickly found a project called OpenCV for Open Computer Vision, and it had Python compatibility. And he grabbed some source code and started hacking, and he did all the motion control. And the game would basically, the webcam would point at the player. We'd get probably 30 frames per second out of the camera. And the job of OpenCV, Open Computer Vision, was to get a keyframe before anything started. So before the player jumps into the screen, you want a perfect picture of the background, and you hold on to that. And then when the player comes in, using OpenCV, it can subtract what hasn't changed and then really exaggerate where the player is and do a bounding box. And he's writing all this code, just hacking it all together. And in 30 days, we had a polished game that had he did the high scoreboard. He did probably the lion's share of the coding and QA and all the computer vision work. So we show up at STEAM Night an hour early to be prepared. At home, the game was working perfectly. At STEAM Night, with an hour to go, we set up, and we're just kind of taking our time because we're ready. We're high fives. This is going to be awesome. Half an hour before STEAM Night starts, we're fully set up. We point the webcam, and the wall behind our booth, instead of being a nice flat uniform color, was stone, and it had lots of nooks and crannies. And the lighting was about 40 feet in the air because it was a vaulted ceiling for the cafeteria. And we never planned for the situation. And the look of panic on his face when we had an autofocusing webcam and it could not find focus. So the keyframe was terrible. And the player would jump in and his software just didn't work. It had no idea what it was doing. And we were scrambling. How are we going to fix this problem in the next half an hour? And I don't know why I thought of this, but to be prepared, I bring things when I go places like this to set up. And something I'd brought was a roll of Gorilla tape, black tape, and I put a big 3-foot by 3-foot black X against this grainy wall, and the webcam just locked on perfectly and did a full focus. We got a keyframe. He jumped in, started playing the game. Everything started working. And again, it was kind of seeing that moment in his eyes. In one night, we worked hard to make a game. We showed up and it didn't work. We came up with a solution on the fly and realized next time we should come in advance and make sure what we're doing is going to work. And the look of delight when he built something that kids came and played, and some kids didn't understand it, but that was the other goal, was no touch, that the player should be able to figure out the game. There's enough text on the screen, but not too much, so the player would know what they're supposed to do. The other thing we found was we had a monitor facing outward, and with little kids, parents would try to help a kid who didn't know how to do addition, say go left, go right. We quickly learned we were flipped. And we never thought to flip the screen. So the parents we had to put a note on the screen saying, if you help your child, tell them the wrong answer, because the kid would jump left when they should jump right because the camera was facing opposite away. And driving home that night, it was a great moment. You know, it was kind of like my Little League World Series with my son. He said, Dad, I know I want to be a software developer now. It was producing something that someone other than him enjoyed, consumed. It made sense. You know, he was explaining how it worked to parents. So it was a really good experience, and it carries on to this day. Last year we did 2 games, and this year he's a freshman in college. So remotely we're going to co-author something that I hope is even more impressive than the things we've built in the past.
That's cool. So by putting yourself out there, getting uncomfortable, taking a chance, you ended up with the perfect lesson where your son got to present, he got to interact with the public and his users, he got to see his stuff used in the wild, he got to have stuff go wrong at demo time and have to fix it, and then he got the satisfaction of, hey, I learned a lot about programming, how this all works, getting it to work with people, and it all started with taking a chance on it.
Exactly. Putting yourself out there, I think that's a good way to put it.
Same thing you did in London, but hey, it's
unanticipated.
You learn from it.
Yeah.
And you're better for it. So, Tim, thanks again for coming down today. We appreciate you sharing your insights, your history and your career, lessons learned, and also passing it on to the next generation.
Thank you. Thanks for having me.
And we'll talk to you again soon on Underserved.